Good morning. Welcome to Biolynceus's first turf webinar. I am Mark Sembach, and I have been with Biolynceus since 2004. My background is in forest resource management with minors in fire management and environmental law. And getting a forestry degree, I had a real heavy science background, and it has given me some great background knowledge to do my job here with Biolynceus. I work in the agriculture field a little bit. I also work in turf management, landscape management, work with arborists, and of course, I also do work with human wastewater and industrial wastewater management. So let's talk a little bit about growing things in soil. So there's basically three different ways that is commonly done. There's the conventional way, where you're generally using chemically based, salt-based, or hydrocarbon-based fertilizers. You're using herbicides, sometimes you're using pesticides. And then there is, on the clear other side of that, there is organic. And prior to World War II, pretty much everyone was an organic farmer. And they would, to achieve the organic status, it takes about a minimum of 3 years, and then you have to be recertified every single year. So it's much more intense, usually manual process, because there are no chemical inputs to help control your pests or your weeds. And it does have a perceived higher value and a higher economic cost, but it may not necessarily be that way per se. And then if you marry those two up, you get what's called sustainable. And sustainable borrows a little bit from conventional, borrows a little bit from organic. And what you can do is you can help improve soils by borrowing some of that organic. And so that's where Biolynceus kind of falls, even though we do offer pure or certified organic programs. We also can work with conventional and make the conventional program more sustainable. So let's talk about some of the benefits of being sustainable. One is you get improved soil fertility. Generally, you get less soil compaction. You get better root zone development because the soils are less compacted. And also you get generally increased pathogen resistance in plants and also in soils. I want to tell you a little bit about the better pathogen resistance in plants. So as we know here in the West, mountain pine beetle is a severe problem. And mountain pine beetle started up in Canada. It was just affected a tiny little area of Canada, and there wasn't much of an impact beyond that area. And then climate change started to happen, and it started moving out of that territory and started moving south. But in addition to that, the U.S. Forest Service back in 1912, was a really bad fire year here in the western United States. And out of that, the Forest Service was born, and it was their duty to put out every single fire that started. And they did that as quickly as possible. And they did that up through about the early 1980s. And by eliminating fire from the Western ecosystem, what happened was there was a whole lot more trees per acre. And when you look at forest soils, generally you have a thin soil, it's fairly depleted of nutrients, and it doesn't hold lots and lots of water because the soil is so thin. And you combine that with the western pine beetle, so all these trees are sending out stress signals. Oh, I don't have enough nutrient. Oh, I don't have enough water because there's too many what I call sticks per acre. And so the mountain pine beetle just continued its march through the west, and it's pretty much decimated a large portion of the trees, the pine trees here in the western United States, and it continues to be a problem. And then other benefits that you can get from using a more sustainable system is you can get less damage to sensitive ecosystems, because generally you're not on the ground or you're not in those systems as often applying either a chemical, herbicide, or pesticide. And so there's less involvement and less impact to the soil because you're not in there as much. Also, you generally have fewer impacts from weeds. And that's because what you're able to do is you're making the soils a little bit more facultative and aerobic, and that gives a chance for like the grass seeds to outcompete the weed seeds over time. Generally, you also have less energy inputs. And one of the things with the less impact of weeds, when conventional fertilizers and herbicides are used, when they talk about herbicides, they talk about them in half-life. So standard herbicide might have a half-life of 5 years. Well, what else that in current society is given in terms of half-life? And that is radioactive materials. So radioactive materials may have a half-life of a couple 100,000 years. And what you have to remember with a half-life is that it's never completely gone, because it's only reduced by half each time. And with herbicides, it is the exact same way. Some pesticides are that way too, where it might be a 5-year half-life. So you never completely get rid of that herbicide if there aren't the microbiology in the soil that can help reduce that herbicide and shorten that half-life and reduce the concentration of it. So if you're applying an herbicide every single year, there is a good possibility that that herbicide or that pesticide is building up in the soil and having an impact on the soil microbiology. So let's talk here a little bit about starting the science portion of this. So around the world, all the soils on this planet have 3 basic components of sand, silt, and clay. And that's basically, we're going to call that dirt. And dirt, you could plant a plant on it, and more than likely the plant would not thrive. The plant probably wouldn't grow very well. And what you have to do is get that dirt and change it into a soil. So when you have a healthy, balanced soil, what you end up with is, of course, that sand, silt, and clay, but you also have humus, you have organic matter, you have living organisms in that soil. There's a client of mine, Siboney Stillwater Mine, and they call it topsoil, but I call it dirt. And basically it's a lot of sand, it has a little bit of clay in it, a little bit of silt, and lots of times there's lots of big rocks. And we have to remediate that and to revegetate that, those soils. And so what we do is we take a couple of our products, Lot 125, which we'll go into later, and also seaweed cream. Both of those products are in a microbial base, and they mix those products in with a hydromulch that has a tackifier on it, because we're working on some pretty steep slopes. And also they have a fertilizer that they like to use. And so we will hydromulch out that solution the first year, go back in the second year, and sometimes we have to do it again. Sometimes we only have to do spot treatments where we're hydromulching that solution down. The third year we go in with just the Lot 125 and the seaweed cream. And by that time the grass is completely established because we've created living soil by adding that microbiology. And then in the fourth year, we're already starting to plant trees and shrubs. And so it's a pretty short cycle, a remediation cycle. And there are lots of mine sites that they're trying 10, 20 years down the road to turn that dirt into soil. And the key thing is they can't get those living organisms to establish. They can't get the organic matter and the nutrient recycling going on that's necessary to happen. So from there, we're going to go into a little bit deeper dive here into why everything works in the soil. So the philosophy for Biolynceus is to farm the soil, not the plant. You have a healthy, balanced soil, you're going to have a healthy, balanced plant. And microbiology plays a huge role in plant health. just like in humans. It plays a huge role in our own personal health. And so it's the same with the plant. So basically, you know, a plant's growing and it's taking in the sun's energy and it's creating sugars. And most of the time, about 50% of the sugars that a plant creates is driven to the root zone of the plant and used in a variety of ways. In evergreen trees, that's in upwards of 85%. And that tells you how important that root zone is to the plant. Basically, the soil is the stomach of the plant. And so what the plant does with those sugars it drives to the root zone is ones it helps develop the root zone, but also it gives it to the microbiology, because that microbiology supplies nutrient to that plant. So let's say a plant wakes up, it's bright and sunny day, and it's feeling pretty darn good, and it's well established, and says, you know, I would feel a little bit better, you know, I could use a little bit more chlorophyll production if I had some magnesium. So it says, hey, microbes next to the root zone of my plant, because there are 100 times more microbes next to within the first quarter inch of a plant's root hair than there is further away. And so they're chemically talking with each other. And so that plant is saying, you know, hey, microbes, you know, I need some more magnesium today. Here's some sugars, because the microbes can't produce those. Here's some sugars, and I'm going to go out and I'm going to give that sugar to you. And if there's some magnesium near you, please go grab that, chelate it, and give it to me so I can feel in tip-top shape. So there's all this kind of chemical communication going on within the soil, and they've now have done research where trees talk with each other, whole ecosystems are talking with each other chemically through the soil. Well, as the growing season goes on, the days get shorter and that plant's going to start to harden off and die. And that dead material goes down to the soil-air interface, where you've got some larger life forms that start to break that, what's commonly called thatch, or in a turf environment, or in a soil environment, just, you know, when I say a treat environment, leaf litter. And there's some larger life forms that start to break that material down. And then it gets down smaller and smaller and smaller, and finally it gets down to a point to where the microbiology act on it, finish breaking it down. They're creating humic acids, they're creating fulvic acids, and they're also chelating the nutrient, so the following year the plant will have that nutrient to regrow again. And we worked with a potato grower. I'll tell you a little story here. We worked with a potato grower in Colorado, and he originally called us and he said, do you sell a nematicide? So with potato growers, nematodes are their nemesis. They can be really problematic and cause all kinds of havoc with a potato grow. And so we told him, it's like, no, we really don't have any nematicides, but we have this other product called Lot 125. You should try that. Works awesome. It should help solve all of your challenges. And so he used a Lot 125, and at the end of the growing season, he had more potatoes. They were bigger, they were better, he had fewer culls, and he ran another nematode test on his soils at the end of the growing season. And when he got that result back, he called us and he said, you're not going to believe this. I've got more nematodes in my soil now than I've ever had before, but they're not eating my potato. So what the Lot 125 did was supplied the correct microbiology in the soil, helped balance out that soil food web, so the nematode was eating a primary food source rather than a secondary food source of the potato. And another thing that's super important when you're looking at soils is to look at total and available nutrient. And if there is a big difference between like total nitrogen and available nitrogen, well, that tells you that more than likely that you are having a microbial challenge in your soil. Your soils aren't well balanced. And if you wanted to do a really deep dive into that, you could do what's called a 6 functional group test, and that would tell you in a lot more detail what the microbiology component is or is not in your soil. So I want to open it up to a question here, and please feel free to answer it. Don't feel you have to, but I want to know, what is the most important nutrient to a plant? Anyone willing to take a stab at that?
Carbon.
Carbon. Awesome. Great answer. Because when you look at what comprises the components of a plant, is carbon right there at 44 to 46%. Oxygen, again, 42 to 44%. Hydrogen, 5 to 6%. Of course, those are the basic building blocks for any living thing here on our planet. But when you're looking at fertilizers, they're always talking about nitrogen, phosphorus, and potassium. And fertilizer companies will tell you every single day, oh, you need to add more nitrogen. Oh, you need to add more phosphorus to your soils to get better growth results. And what they have found is that over time, as you add more and more chemical fertilizers to your soils, you start to affect that the soil microbiology, and you get short circuits in that soil food web. And so when you're looking here with nitrogen, you know, a plant, its component is only 3 to 5%. You can get that in the form of nitrogen dioxide or ammonia, and it's involved in the amino acids and protein production, and also chlorophyll. When you look at phosphorus, it's less than 1%. And that's involved in the genetics portion of the plant. If you remember from high school, ATP and ADP. We're not going to dive into that. Also, potassium. You know, potassium can be upwards of 6%. And that's really important because it controls osmotic pressures within the cell itself. It's what is called its ionic balance. And then also, of course, calcium is the basic building blocks of soils, or I'm sorry, of plants. So it's used in the production of cell walls and membranes, also enzymes. Magnesium, of course, as I said before, used in the production of chlorophyll. And then also sulfur for the production of amino acids, proteins, and different types of enzymes. So when we're looking at that leaf litter or that patch layer that needs to get broken down, if you can still recognize what that material is, it's called organic material because it's still recognizable. And it starts with varying degrees of decomposition. You know, with if you're a landscaper and you're you know, you're mowing and you're leaving those clippings out on the lawn, well, eventually those clippings work down into the soil air interface, and you get a thatch layer that may build up over time. And if it continues to build up and is not breaking down for whatever reason, if there aren't the little soil critters, or if they've used a pesticide on the turf to kill ants or something like that, these thatch layers can build up and they can create anaerobic zones. It can get so thick, and there's an awful lot of pathogens that can build up in that mucky black zone. But what you want to get to is what's called humus. And with humus, you're not going to recognize what that plant tissue was, what that original tissue was. It's going to be completely decomposed. And when you completely decompose those materials, there's humic acid, there's fulvic acid, and there's humin that are the byproducts of that decomposition. There's a lot of other biological breakdown byproducts, dead microbes, of course, in their waste. And also there is a lot of chelated nutrients. And a little thing here about humic acid. So when the Russian scientists started breaking down soil molecules, first thing that they derived was an acid. It's called fulvic acid, very beneficial acid to have for the soil. It has about a 3.5 pH. But humic acid is actually, it is an alkaline. It has more of an 8 8.5 pH. And so that is more of an alkaline. So humic acid is actually incorrectly named, but they just never have changed it. So what are the benefits of having a healthy, balanced soil food web? One of them is you can get improved water holding capabilities in the soil. You can also break down clay compacted soils or caliche soils. You get better aeration in those soils as a result, and you're making them more facultative and more aerobic. And then you also get an increase, you can increase organic matter in sandy soils, because sandy soils, they can't hold on to water very well, they can't hold on to nutrient very well. But if you start properly managing them, you can get them, you can just gradually increase the organic matter content. Another thing you can do, and this is really important to park managers and sports field managers, is to monitor the GMAC ratios in soils. Basically what that means is it is the pressure at, it's a force measurement that, like if a little kid's knee hits the ground, the soccer field that he's playing on, or an elbow or a hand or his head. And you want to reduce those GMAC forces so you don't have super compacted soils. And the tool that they use to measure that with, as you see there on the right, it's called the soil compaction tool. And basically, it's got the two handles on the right with a long pointy stick that will you'll push down into the soil. And as you push that into the soil, you're going to see that gauge rise. And it'll go from the green zone to the yellow zone to the red zone. And once it hits the red zone, that is the point at which roots can no longer penetrate that soil. And I've used that to where I've been on sports fields where within 1/4 of an inch of the surface of the soil, the compaction tool was already at red line. Then I've gone out to some areas where there's natural grasses and things like that, and pushed it in more than a foot, and it never even got close to that red line. So it's very, very important to manage those soils, especially on sports fields, to reduce that GMAC ratio as much as possible. And so that's why you really need to have that healthy and balanced soil food web. So when you're looking at a healthy and balanced soil, you're going to get better water absorption, and you're going to get, the plants are going to have improved water uptake, because they're making, as you're getting better water absorption, that generally means you have less compacted soils, and so your root zone is developing deeper into the soil, and you're creating spaces for water and nutrient to hang out right within the root zone of the plant. Lots of times you go on a golf course and they have unintended water features where there was a big rain event or they over irrigated a fairway and there's standing water there. Well, that's because the soil below it has a compaction problem. And so other benefits you can get, I worked with a golf course in eastern Montana called Ponderosa Butte Golf Course, and all the water to irrigate the course with comes from the wastewater treatment plant. And out in California, they use an awful lot of reclaimed water on golf courses. In Colorado, they also do it. New Mexico, lots of different places where they're using this reclaimed water. The problem is that reclaimed water generally has higher salt content, and it has other components to it that can make growing grass with it quite challenging. And the golf course there in Colstrip, Montana, Ponderosa Butte, they would bring in the water from the wastewater treatment plant into a 2-acre pond that they would use for irrigation. And over time, that 2-acre pond gradually filled with algae because of the nutrient that was coming in from the wastewater treatment plant. And they're having all kinds of problems trying to run their irrigation pumps because the algae and the weeds that had grown up kept plugging them up. And so they approached us and they go, do you have something that you can use to get rid of this algae in our ponds? And I said, yes, we do, and we'll cover that here a little bit down the road. We do have a liquid microbial solution that we can help reduce algae in ponds. And so they started using that, and over the course of 2 years, we digested about 95% of the algae in their pond by helping reduce their sludge blanket, so it wasn't leaching phosphate into the water column. Did some amazing things, but all the time they were using that to irrigate their course with. And what we ended up doing was the microbiology that was going out from their pond to the course, we digested their thatch layer that had built up. Excuse me, we eliminated all of the turf pathogens that he had in the course. And also we helped them use less fertilizer and less water to grow his grass. And what he said to me, he goes, since I started using your pond product, your probiotic scrubber 1, I'm using less water and less fertilizer to grow the grass on my course and manage it, and the grass is greener than it's ever been. At times he was using 30% less water and 50% less fertilizer. So lots of times just managing, he was just managing the algae in his pond, but he saw all these other benefits from adding microbiology back into his soils. So what are some of those products that we use? Commonly for turf and tree management, landscape management, also in agriculture, we use a product called Lot 125, and that's humic acid, fulvic acid, and humin in a microbial base. As you see, that product is certified organic by the, it's OMRI certified organic, so it's going through that whole process every single year of getting its organic status recertified. Another product that we use is seaweed cream, and that's exactly what it is. It is cold processed. It's sea kelp from the North Sea, and what the seaweed cream has is the kelp. It has a whole lot of plant hormones in it, cytokines, gibberellins, auxins, and what those plant growth hormones do is they help develop the lateral root hairs of plants. And so as you're alleviating some of that clay compaction with the lot number 125, you're using that seaweed cream to help populate those areas to grow that root zone of the plant. Another common product that we use in turf management is called Turf Master 1253. Now, when you look at our nitrogen number, it's really small compared to a lot of turf products that are out there. Like a common one you use is called UM32, so it's 32% nitrogen. And what you have to remember is that that nitrogen is not in a chelated form for the plants to uptake. So unless your soil that you're applying that to has the correct microbiology to chelate that nutrient into an available form for the plant to uptake, once that nutrient gets past the root zone of the plant, it basically becomes a contaminant in the soil. So with our solutions, since we have the microbiology that's chelating all of that nutrient, we can go in at a lot lower percentage of nitrogen, and upwards of 100% of that nitrogen is available for the plant to uptake. But you'll notice that this product is not certified organic. It comes in an organic base, but anytime you get up above a 6 or 7% nitrogen content, you have to go to a chemical form of nitrogen to get that. Other products that are used, especially for our arborists, are in other landscape managers, is called 888, and that's just a straight across the board nutrient. Trees like it, other types of trees and shrubs all kind of like it. It's just, it's not a super amount of nutrient, but it's enough to make them happy. And you'll see that that one is not certified organic, again, because once you get above that 6 or 7% nitrogen content, you need to go to a chemical source to get it. Another product that's commonly used is called a chelated iron product that we have, called iron at 4%. And lots of landscapers use this. Also, arborists use this. If they're having a problem with either grass that's a little bit chlorotic, or maple trees, or some other types of tree that is a little bit on the yellow side of things, And what you can do is you can apply this iron to those trees and help green them up. And it helps them with their whole production of chlorophyll and the production of those sugars that they need to drive to the root zone of the plant. Another product, as you see, that iron product is certified organic. Another certified organic product is called fulvic acid. And fulvic acid has what's called a real high cation exchange capacity. And I won't do a deep dive into that, but suffice it to say, what a high cation exchange capacity allows the grower to do is to carry compounds, chemicals, nutrients through the cell wall structure of the plant right to the plant for immediate use, rather than applying a fertilizer that has to go down through the root zone of the plant and then have the roots uptake it to get to the leaf. Well, you could apply a fertilizer if you wanted to, along with fulvic acid, and you can bring it directly right through the cell wall into the plant so it can use it much, much quicker. Again, that is a certified organic product by the Organic Materials Research Institute. So here's a little bit of application protocols for trees and shrubs. In 400 gallons of water, you add 10 to 15 gallons of lot 125, 32 to 48 ounces of seaweed cream, and then 3 to 5 gallons of 888, and the option is to add iron at 32 to 48 ounces of iron into that solution. And the reason why you see a range in those application rates is the lower application rate is at a lower elevation. If you're working in higher elevations, you need to supply more nutrient much quicker to those environments since they have shorter growing seasons. And so it just depends where you're at in that elevational range as to whether, if you, like with lot 125, if you use 10 gallons or if you would use 15 gallons. But with that mixed solution, you either deep root or inject into the ground at 1 gallon per inch in diameter of tree. If you're planting trees or transplanting trees, what you want to do is fill that planting hole half filled with that solution that you've made that has the lot 125, the seaweed cream, and the 888, and iron possibly, and then fill that hole half filled with that solution, plant your plant, and water it in with that solution. And your plants have the microbiology necessary to get established, and they can get established very, very, very quickly. When you're looking at doing applications for turf, the application rate for lot 125 is 30 gallons per acre per year. Seaweed cream is 3 gallons per acre per year. Turf master, 12 to 15 gallons per acre per year. And iron at 3 gallons per acre per year. And you want to apply all of our products mixed a minimum of 10 to 1 with water. And you can break up this application. Generally, turf applicators will have at least anywhere between 2 to 5 applications of fertilizer a year. And you just break up those per year applications into the appropriate number of applications that your company is going to be doing. And like I said, you mix all of those products 10 to 1 with water. So there's, like we've been talking about, there's huge benefits to having a sustainable program where you improve the root zone of the plant, you can improve how that root zone develops, you can use less water, and lots of times the savings that you see in water and fertilizer savings will more than pay for the cost of our product. Well, we have a client, City of Aurora, Colorado, and City of Aurora had built a brand new city hall, and the park staff was doing all the landscaping and planting all the new plants for the new city hall. And so they were using a solution of the lot 125 seaweed cream to plant all of their plants. and they had, that solution mixed up in 400 gallons of water. And they were going along and they were planting the plants, and then it got towards the end of the day, and they ran out of that solution. They didn't want to have to run back up and mix up a new batch of it back to their shop. And so they continued planting the plants for the rest of the day, and then the next day came back with a full load of the lot 125 and seaweed cream already mixed up, and continued planting. But they never went back and treated those plants from the previous night that never got the lot 125 and the seaweed cream. And you can see to the plant on the left, plant on the left got treated, the plant on the right did not. And when you look along, we have another photo of this whole line of plants, and you can see to the plant where it ended on one day and where it started the next day, and all the plants in the middle, because they were significantly smaller and it took them longer to get established. The way the city of Aurora actually learned about our solutions was we had a client that was using our liquid microbial solutions, the lot 125, the seaweed cream, the turf master, and the iron, to treat his yard down on the Front Range, where there's lots, frequently they're in drought situations down there, and there's a lot of people, and so they put in severe watering restrictions when these drought conditions happen. And I believe they can only water once or twice a week. And the guy here with the untreated lawn, he saw that his neighbor's lawn was nice and green, and so he actually called the city of Aurora, and their water cops came out and did a water study on our client's lawn. And what they found out was that the client was using less water than what his neighbor was, and he ended up saving over $1,500 that summer in watering costs and irrigation costs. And so, but his neighbor, the one with the untreated lawn here, was using more water than him. And so the city of Aurora said, well, heck, let's do this with all of our park services too. So that's how the city of Aurora became a Biolynceus client. Other things that we can help remediate is sometimes landscapers or arborists may have a challenge with a chemical compound that gets spilled on soils. In this case, it was a hydrocarbon. A mower's gas line started to leak, and it created all these stripes in the lawn where the hydrocarbon was killing the lawn. Well, if we can catch that quick enough, we do have a solution, a microbial solution called Probiotic Scrubber that you can apply to those turf surfaces, and more than likely you will not have to replace that sod or replant that grass area, because the microbiology will break down that hydrocarbon and as a food source and completely remediate it. And so if you, let's say also we can do this with herbicides, we can break down herbicides if you have an herbicide spill. So there's a lot of different uses for microbiology. Again, if you have one of those spills, by all means, please do give us a call, and we'll be completely honest and see if we can help you out or not. Other things that we can do is we can work with sodic soils, alkaline soils, where there are alkaline seeps. This was actually a well that a project that I worked on in western North Dakota. And what happened was that the well over here on the top left-hand corner was called a Christmas tree. But anyways, this little Christmas tree is a series of pipes and valves, and it got overpressurized and it blew up basically. And it started spewing out hydrocarbons and salts that killed off 22 acres in 20 hours. And so there was 11 acres on the north side of the road and 11 acres on the east side of the road. I'm sorry, 11 acres on the north side and 11 acres on the south side. And what they did is they completely took away all the vegetation on the north side of the road down to bare dirt. And on the east side, on the south side of the road, they just cut the vegetation down and hauled it away. And then we went in with our lot 125. I had a little bit higher application rate at 40 gallons per acre per year. and also another product we have called Go Green Super Algae. And we applied that product to both sides, the north side and the south side of the contaminated area. And they split that into two applications in spring and fall. Originally, we designed this remediation program to last 3 years. And the second year, they went in again and made two applications, spring and fall. The third year, the wellhead had changed hands for the third time, I think, and no applications were completed. But what we did, the Forest Service asked me to go out there and do an evaluation of it. And what I saw was just the area was completely populated with wildflowers and wild grasses. The reseeding that they had done after they had applied our product the first time had taken hold. There were partridge in there were quail in there, the rattlesnake was still there, unfortunately. But what was pretty amazing, they ran another soil analysis afterwards. And right after the well had blown up, the soil samples were showing an SAR, a sodium absorption ratio of 17. And what we did by applying our liquid microbial solutions, we dropped those SAR ratings all the way down to background, which was 6 and 7. So we did that in a 2 to 3 year time frame by just supplying microbiology to those soils. So if you have some soil, some salt impacted soils, that is definitely something that we can work with. This is a turf farm down on the Colorado Front Range. It was using lot 125 in seaweed cream, and what they found out when they started using those is that they didn't have to take as much soil with their rolls. So their rolls were, since they were taking less soil, were significantly lighter. And also they were, they could hold them on a truck longer. They're able to hold on to water longer and transport further distances without losing any of the turf. And with his water savings, he was able to actually grow more acres of turf because he only had a certain amount of water that he could use because, again, water is scarce on the Front Range. And by using less water to grow his grass, he was actually able to expand the turf production area and increase his profits. And one from my landscapers here in Montana, especially in Gallatin County, there's been a significant increase in the organic inputs since about 2014. There's a lot of landscapers who have come on board using our liquid microbial solutions. And what they have found out is especially at elevation, up in the Big Sky area, up at those higher elevations, adding the extra microbiology to those soils makes significant improvements in plant health, in turf health, because classically up at elevation, snow stays much longer, you have a much shorter growing season, your soils are very thin, and so they're freezing and they're losing a significant amount of microbiology over the course of the winter. And as the snow goes away and those soils heat up, then the microbiology will start to grow and reproduce again. But the problem is that it takes a little while for that to happen. And your growing season is, 2.5 months, probably maybe 3 months at most up at elevation. So by going in early in the spring and supplying the microbiology that our liquid microbial solutions have, you can get significant improvements in turf health, in tree health, in plants establishment. And it's just looked really, really just amazing improvements when you're using our solutions at elevation. Another, for those of you who manage sports fields or spray sports fields, you can help keep down resodding costs. Classically, the way park managers handle turf surfaces is that over time, after so many years, they will just go through scrape off all the old sod, old grass, and put new grass down. And that's because those grasses, they get compacted. They'll start to get standing water again. Those GMAC forces go up because sometimes those fields are played on 10 months out of the year, and the grass doesn't have a whole lot of time to recover. So when you go with a more sustainable approach, when you're actually farming the soil, not the plant, applying our Lot 125, our seaweed cream, you can get those sports turf surfaces to recover much quicker. And lots of times you don't have to go in and resod those fields, or if you do, you're doing it a lot less frequently. And so ultimately, they're saving money by not having to completely resod those surfaces. This is Buffalo Run Golf Course. This is the site of an old alfalfa field, and it had a lot of challenges. And the golf course superintendent was having problems with sodic soils, alkaline soils, and he couldn't get his grass to establish very much. And so he approached Biolynceus, and he tried us on 2 fairways. And over the course of 2 years, he had some excellent improvement in soil health, which helped improve his turf establishment. He had some compacted areas. The compacted areas were no longer there. And so he started using us on the rest of the course. And it took 3 years for the fairways that he hadn't treated to catch up to the 2 fairways that were treated the first year. Also, other things that we can do is we can reduce turf pathogens. And turf pathogens, they can be fairly impactful, especially in sports fields. And one of them that we can remediate is actually fairy ring. And I worked with Casper Parks and Recreation, and basically Casper Parks and Recreation had 11-acre sports fields, and it had really low organic matter content, and they needed a way to improve that so they could get better water holding capabilities. And they thought to themselves, well, we cut all this grass and we have all these leaves and sticks. It's like, well, we could make our own compost, which is the source of organic matter, and we could apply that to those sports fields and improve them. Well, so they did that, but the problem was they didn't get their compost up to appropriate temperature. I think it's at least a minimum of 150 or 180 degrees to sterilize those turf pathogens. And they applied that compost that they had created to those 11 acres of sports fields, and basically came up with 11 acres of fairy ring. And over time, the center of the fairy ring will die out, so you have all these bare spots where grass doesn't grow, but right where the mushrooms are at is bright green. So you have all these concentric circles that connect with each other. So they started using Lot 125, seaweed cream, turf master, and iron, and then one of our wastewater products, that probiotic scrubber 1. And over the course of 2 years, we remediated 99% of all of their fairy ring by just using the microbiology, because the microbiology find the fungal hypha underneath the soil of the mushrooms as a really good food source. Also, as I alluded to before, is we can help reduce algae in ponds by using our microbiology. This is a golf course in south central Montana, where 50% of the water comes from the wastewater treatment plant. Again, it's reclaimed water, and 50% comes from the Yellowstone River. And over time, their pond had built up a sludge layer that was, as it was decomposing, it was releasing phosphate into the water column. And the algae really like the phosphate, and the pond is fairly shallow. It's only about 5 or 6 feet deep, and so it would heat up in the sun, and they would just have these continuous algae and duckweed blooms. And over the course of 3 years, we applied our liquid microbial solutions, probiotic scrubber 1, to the intake and the various points in that pond, and we reduced the amount of duckweed and algae by over 90%. And so they were very happy. They actually had blue clear water rather than pondweed and duckweed covering the entire surface of the pond. So I'd like to open this up to any questions. Does anyone have any questions whatsoever? I'd be more than happy to answer them. If I cannot answer it, I will take your name down and your telephone number, and I will get the answer for you. Also just want to say here real quick, some of the things that I've covered come out of the Soil Biology Primer. It is an excellent, excellent, excellent source if you want to do a little bit deeper dive into soil microbiology and why it's important. It's not super technical. It's very easy to read. It's a very short read. It's put out by the Soil and Water Conservation Society. Highly recommend that for any turf managers or people using our liquid microbial solutions, because it tells you why we do what we do. So are there any questions? So I would like to end our presentation here. Since I didn't hear any questions, please do like us on Facebook and also visit us. We have a brand new website at biolynceus.net. There's a ton of information on there, from articles, different products, articles from our clients, and please do look at that site. And again, please like us on social media. I would like to thank you all for attending this session. And if you have any questions, by all means, you can contact me via my cell phone or my office phone, or you can contact Biolynceus corporate office in Estes Park, Colorado, and they can help you out there also. Again, thank you for attending. I greatly appreciate it, and have a fantastic rest of your day.